So, hello dear students. After very long time, I welcome you for this class. Now today we see the deduction of Wein's distribution law from Planck's law of heat radiation. Now, last time we have learned or we have derived the Planck's law of radiation. तर प्लँक्स लॉ ऑफ रेडिएशन हा आपण गेल्या वेळेला डिराईव्ह केला आहे. जर तुम्हाला आता ह्या लेक्चर ते माहीत आहे असं समजून मी पुढे घेते, तुम्ही परत वाटल्यास तो व्हिडिओ बघा. आता प्लँक्स लॉ ऑफ रेडिएशन काय सांगतो की एनर्जी डिस्ट्रीब्युशन इज नथिंग बट इट इज दिस इक्वेशन दॅट इज ई लॅम्बडा डी लॅम्बडा इट इज इक्वल टू 8 पाय एच सी अपॉन लॅम्बडा रेज टू 5 d lambda divided by e raised to hc upon lambda kt minus 1. So this is the equation just. Now this Wein displacement law is applicable for short wavelength. So this law is applicable for short wavelength. So we can say that. So this is, if it is applicable for short wavelength, so wavelength is very small, therefore we can say that this e raised to hc upon lambda kt is large, and since it as large, so we can neglect here 1, so we can say that e raised to hc upon lambda kt is very much greater than 1, and therefore we can write like this: e raised to hc upon lambda kt minus 1 is approximately equal to e raised to hc upon lambda kt. And there we solve this. So it is very simple. E lambda d lambda equal to 8 pi hc upon lambda raised to 5 into d lambda divided by e raised to hc upon lambda kt. Directly we can say that. लॅम्बडा शॉर्ट आहे ना, इट इज ॲप्लिकेबल फॉर शॉर्ट वेवलेंथ, आणि सिन्स शॉर्ट ही लॅम्बडा जर लहान असेल तर ई रेज टू एच अपॉन लॅम्बडा केटी ही लार्ज क्वांटिटी आहे ॲज कम्पेअर टू 1, अँड देअरफॉर वी निग्लेक्ट हिअर 1, अँड देअरफॉर वी गेट दिस. सो आय विल रीराईट अगेन दिस इक्वेशन. आय विल स्कोर आउट. सो वी कॅन सी दॅट जस्ट ई लॅम्बडा डी लॅम्बडा इक्वल टू 8 पाय एच सी lambda raised to minus 5 d lambda, so that is into e raised to minus hc upon lambda kt into d lambda. हे वर घ्या आणि lambda raised to minus 5 हे वर घ्या. So we can write हे constant quantity आहे ना, this is the constant quantity. I will score out this. So put 8 pi hc lambda minus 5 is equal to e. I think it is like this. No, 8 pi hc we can don't write it. एवढं 8 pi hc constant आहे, so it is equal to e, and put minus hc upon lambda kt equal to small e, and therefore our equation becomes e lambda d lambda. So we can नाही एच सी अपॉन लॅम्बडा, तर लॅम्बडा इथे कॉन्स्टंट नाही, एच सी अपॉन के टी इक्वल टू ई. वी कॅन टेक ई लॅम्बडा डी लॅम्बडा इक्वल टू ई लॅम्बडा रेस टू मायनस 5 ई रेस टू ए अपॉन लॅम्बडा डी लॅम्बडा. So this equation is called as Wein's displacement law, which we have derived from Planck's law of radiation. सोपं एक्सप्रेशन आहे, फक्त काय करायचं, सबस्टिट्यूट करायचं. किंवा ह्या इक्वेशनला जर म्हटलं Wein's displacement law, पुढचं लिहिलं नाही तरी चालेल. सो दिस इक्वेशन रिप्रेझेंट Wein's displacement law. So we have derived this equation from Planck's law of radiation. So this is first point. Now we go for next topic. Deduction of Rayleigh-Jeans law. So I will Rayleigh-Jean's law from Planck's law of radiation. So I will put like law. Now this law is applicable for longer wavelength. Wein's displacement law is applicable for shorter wavelength, and this is short wavelength, and this law is applicable for longer wavelength. Again I will write like this. So we have this E lambda d lambda equal to 8 pi hc upon lambda raised to 5u into, I think, d lambda, so divided by e raised to hc upon lambda kt minus 1. So again we can here take the approximation for longer wavelength. So we can write like this: e raised to hc upon lambda kt is approximately equal to 1 plus hc upon lambda kt. The expression says for longer wavelength, what happens? This term becomes short. E becomes exponentially, term becomes short. So e raised to hc upon lambda kt can be written as approximately equal to 1 plus hc upon lambda kt, and hence above equation becomes, I will write here, e lambda d lambda equal to 8 pi hc upon lambda raised to 5u d lambda divided by 1 plus hc upon lambda kt minus 1. So this get cancelled, and again equation 1 becomes, so this is equation 1 तरी म्हटलं तरी चालेल, पण आहे above equation becomes म्हणूया आपण. So we'll write here, so e lambda d lambda equal to, so this h get cancelled, hc get cancelled, so again 8 pi lambda raised to minus 5, नहीं लॅम्बडा raised to minus 4 लिया, इथं minus 4 के वरती जाणार ना, हे लॅम्बडा इथं कॅन्सल, लॅम्बडा 4 इंटू kt वरती जाईल इंटू d lambda. So 8 pi, so we can write like this, किंवा असं लिहू शकतो आपण. So we can write like this: e lambda d lambda equal to 8 pi lambda raised to 8 pi kt असं लिहूया पहिल्यांदा, 8 pi kt lambda raised to minus 4 d lambda. So this equation is called as Rayleigh-Jean's law. So it is Rayleigh-Jean's law, that is e lambda d lambda is equal to 8 pi kt lambda is minus 4 d lambda. So this is applicable for longer wavelength. So आजच्या पुरते एवढंच. थँक्यू.